In this next lesson, we're going to cover variables in Scala. To do that, I'll switch over to the REPL for a few moments. There are two types of variables you create in Scala. One is a val variable, and the other one is var. I'll cover val first, and a val variable is immutable. And so what that means is I create a variable like this, where with the val keyword here, and then first name is the name of the variable, and then this is the value of the variable. And a val field, once you create it, the key about it is immutable, and that means you cannot reassign it. So this is going to fail, and you'll see this reassignment error right there. Compared to other programming languages, Kotlin took the same approach and has val and var fields. The val field specifically is like final in Java, like let in Rust, or const in JavaScript. I mentioned this here in the book, and it may seem unusual that a variable can't vary. And where this comes from is that a val field is a variable in the algebraic sense. So this means, like in algebra, once you assign a value to a variable, it can't be changed. And this might seem like a limitation. I remember when I first started learning Scala, I was like, oh, what am I going to do? Or how am I going to do anything with this? And then it turns out you end up learning a huge amount about programming just by following this rule. And basically what you do is we make every variable in Scala a val field, unless you have a good reason not to. The other type of variable you can create is a var field, which again is mutable. And I can show that in the REPL. So here I say var first name equals Alvin, and that works fine. And the key here is that I can change that over time. And so a var is just a mutable field. And this is similar to the default variable in Java, one that's defined without the final keyword. And it's like let mutable in Rust, or let mute in Rust, I should say, or a var in JavaScript. And then once again, I'll come back to this point. Val and var are the two ways to create variables in Scala. And our rule is that you will always declare variables as val unless the variable really does need to change over time, in which case you create it as a var. And this does a couple of things. Number one, as I noted in my book, it makes your code safer because you don't have to worry that the variable will unexpectedly be changed later. So you make it a val and that can't happen. And number two, this is a real key indicator to other programmers when they look at your code. When they see a val field, they see, oh, okay, that's a normal immutable field. It's probably used 95% of the time. And then when they see a var field, they think, aha, oh, and a light bulb goes on over their head. And they say, okay, you have to keep an eye on this variable because it can change over time. And on a personal note, this was very new to me. In Java, I didn't even think about this, maybe because my degree was not in computer science, but I rarely, if ever, used final. But now in Scala, like I mentioned, I use val somewhere between 90 and 100% of the time. Also in this lesson, I want to cover the difference between implicitly and explicitly declaring data types when you create new variables. So far, I've primarily shown that when I create a variable, I just say a equals 1, and you know that's going to be an int. And then I've shown strings, and then I could say val b equals hello. And I mentioned that anything enclosed inside double quotes is a string. And the key of this is that you're typing very little. So I just type this, and then the compiler is able to infer from this value right here, Al wants an int by default. So I will make that data type an int. And the same thing happens in this example where I put my value inside double quotes. And the compiler says, oh, okay, double quotes, that's going to be the string type. Or B is going to have the string data type. And the compiler does this implicitly. But next, we can also make this more explicit. If and when we need to, we can say a:\int equals 1. And again, you can, when you look at that, it's obvious to you as a human being, you don't need to explicitly declare that. But if you wanted this to be a long instead of an int, you would need to specify long there. And here you're explicitly telling the compiler, I want this to be a long, or I want this to be a short, or I want it to be, let's say, a float or a double. And all these examples show what I mean by explicitly declaring the data type to be short, float, double, etc. And the way this works is when you create new variables, if it's a small integer value like this, the compiler will say, oh, okay, you want an int by default. And if you enclose a string in double quotes, the compiler will say, oh, okay, that's a string. And if you use single quotes around a character, the compiler will say that's a char value. And so these things happen by default is what I'm trying to show. And the same thing happens with true and false values. Those are Booleans. And then if you want a double by default, you just include a number that has decimal in it like that. So something like y equals 1.23. And when the compiler sees the decimal, it's going to default to a double. But in all these other cases where you want a short, a long, or a float, you have to declare those explicitly, as I showed before, which goes roughly like that. For short and for a float. There's also a shortcut that you'll see programmers can take for floats and longs explicitly. So you can create a float by following the number with an F, like that. And you can create a long by following that number with an L. And just to recap what I just said, this section shows that when you create a new variable, you use either the val or var keyword to say, I'm about to create a variable. And in this example, the variable name is name, its type is string, and its value is John Doe. And then in the second part there, I show the difference between the implicit and explicit formats or styles for creating new variables. And one more thing I want to show, since I got into this topic, is the ranges for these data types. So I include this in my book. It's also on my website, and I believe you can find it on the Scala website as well, the official Scala website. But I show the ranges for possible values. So for instance, here's a short, the possible values for a short. So if I try to create a short, equal, let's say 50,000, you'll see that you get an error there. So the compiler is saying, I'm expecting a short, and you typed in a value that was much too large for this range right here. And then the last point I'll make is that when these other values are not good enough for your needs or not big enough for your needs, you can also use big int and big decimal.